Hello and welcome everyone. My name is Michael O'Sullivan. I am VP Sales at SimActive, and I'm excited to welcome you to today's live workshop, Large-Scale Aerial Mapping, How Do You Make It Work? So today's session is all about tackling the realities of mapping massive areas from the air, from choosing the right sensors to planning efficient missions to managing huge amounts of data. And I'm joined by Dr. Mohsen Miri, Director of Global Strategic Partnerships at Phase One. So Mohsen, thank you for being with us today. Could you start by introducing yourself and telling us a little bit about your role at Phase One?
Greetings to you, Michael. Thank you for having me, and hello to everyone, wherever you are in the world, and I hope you have a great time. Yeah, my name is Mohsen Miri, Director of Strategic Partnerships at Phase One, with background in connecting the dots between products, solutions, workflows, and also everything that customers would need to get their jobs done.
Very good. Thank you, Mohsen. So before we dive in, just a few housekeeping notes. Like every time, if you haven't already, make sure you subscribe to the SimActive newsletter, which are product updates, case studies, and workshops like these ones. You can drop your questions at any point during the webinar or during the workshop in the Q&A box. A member from our team will reach out after the event and provide you with an answer. And finally, stay with us until the end. We always add a short live Correlator 3D demo at the end, so stay tuned for this. So today we'll be covering choosing optimal sensors and settings for large areas, planning efficient missions for wide coverage, managing data volume and quality at scale, and finally, building processing workflows for massive data sets. So again, thanks, Mohsen. Great to have you here. Let's jump in.
Thank you.
All right, so let's start at the beginning, which is sensor selection. When mapping large areas, your camera choice and acquisition settings directly impact both efficiency and final accuracy. Key considerations include sensor specs, obviously, flight altitude and coverage trade-offs, so all the flight planning, radiometric quality and dynamic range, and calibration and stability over long missions. So Mohsen, from first questions to get things going, from your perspective, what should teams prioritize when selecting sensors and configuring settings for large-scale projects?
Thanks for the question, Michael. I think it is important that we start the story backwards, right? So it has 3 whats, and probably the last answer or the last what would be the sensor. The first question would be, why are we doing this project? What is the purpose of this project? Why are we capturing some objects, some features, right? The purpose is the most important thing, right? This is why we defined the strategy at Phase One: pixels to perception. Pixels is definitely the mission and the vision and the passion of Phase One, but the perception is what comes from the customer side, what we are going to extract. Right now, the AI is hungry of data,
Sure.
high qualified data, and it is waiting for extracting features to make the decisions right. So before we start on the sensor, I think it's important to say what we are going to capture, in which dimensions we are going to capture. That means what is the object, what we need as outputs, what is the workflow. These 3 are really important. And then the answer of what should we choose as a sensor, I think automatically will be, let's say, answered and done, right? So choosing the sensor depends on, let's say, which channels, for example, are you going to capture? Is it 4-band? Is it multispectral? Is it, let's say, just RGB? Is it combined with other sensors, fusion of sensors, like with thermal, like with LiDAR? And then goes to the workflow, how we can process it. And what I can say, it is the flexibility at phase one sensor offering is you can do from small projects to medium level projects and to larger scale projects, right? At phase one, there are some pieces of puzzles, or let's say Lego pieces, that you can put them together and make your own sensor. We call them components of phase one technology, and which is integrated in many hybrid sensors outside. And we have also the already compact systems and also full systems for very ultra large scale, right? It is, let's say that the compacts are 150 and let's say 280 currently. And we are working on the new generations of the solutions based on the recently released 250 sensor.
Sure.
And it goes towards the other paths, phase one aerial system solutions like PANA and so on.
Very good. Thank you for the reply, Mohsen. So perhaps a good follow-up question, Mohsen. How do you balance resolution versus productivity in the context, for example, of a topographic mission?
Great questions, Michael. I think it's important that we adjust somehow the question regarding the resolution. Your main purpose would be quality, advanced quality, and resolution is one of them. GSD, ground sampling distance, is one of them. Pixel size is one of them. And also the geometry of the imagery and sensor and calibration. Everything is in a package of quality, right? And then it goes to productivity. So if we come back again to the topic of AI and feature extraction, reliable data plays key role in extracting right and correct and the defined features in AI workflow. Quality is the most important thing, right? Productivity is related to the element of time. And time is one of the costs that we have to consider, right? Productivity always means, okay, what is my profit? How fast I can get to the results, and how much I am close to the quality that is expected, right? And productivity is not only a matter of sensor, it is always a matter of processing and workflow. And this is exactly the role of your software, your solution, your packages at SimActive, that to play a complementary part of that productivity, right? And this is important at phase one, that we're proud and rely on the quality, because we are doing more than 30 years famous in premium level photography segment, came from, let's say, beauty, high quality imagery to the geospatial, and could set benchmark on the high quality imagery. And the productivity would be a combination of data acquisition, planning, let's say, operation and processing, pre-processing and post-processing. So I hope I could handle this question to some extent.
No, that's very good. That's very good.
Right in the choosing the right solutions, and have the job done.
Yes, very good. Perhaps like a quick follow-up question would be like, are there any common mistakes you see? I don't know if I want to call them mistakes, but you know, misconsiderations perhaps that people do at this stage. What would be something someone should consider at this stage, essentially?
Good point. They are not mistakes, right? They are
Right.
exactly as you mentioned, misconsideration, misunderstanding, or not defining the right terms. And all of them are experience, right?
Sure.
And so in each workflow, in each process, in each project, we gather experience, but we should avoid expensive experiences, right?
Sure.
So these type of uh, misunderstanding or misconsiderations are mostly coming from the definitions. Okay, some people would say exactly as I mentioned, if I capture with lower GSD, would that mean high resolution, right? Would that mean high quality? If I just capture the images and just process it, would I achieve the data that I'm expecting, right? No. And there are so many things on the way that should be considered, like calibration, like adjustments, like setting the right parameters. I don't know, in before area triangulation starts and takes time, sometimes hours, sometimes days, sometimes weeks, depending on how large your project is. Should avoid any mistakes that has happened in the past, right? And learn
Right.
it and uh, not making that mistake, right? So these are very important. Um, and then bring that in your workflow and make repeatable, right? That workflow.
Indeed. Absolutely. And perhaps a final question, Mohsen, would be, and obviously we touched a little bit about this already, but do different project types push different sensor strategies? And obviously I'm sensing the answer is yes, but could you expand a little bit on this, and perhaps even give an example or two of a specific phase one sensor with a specific application? I think that would be interesting.
Uh, I have two answers, two right answers.
Okay.
Uh, the first right answer is yes, as you have it, and the second right answer is no.
Okay.
And it depends on the project, right? If we say yes, that means the project types are so different, and the characteristics of the projects and the object, and again to the perception and the feature that we are going to extract, are so different that we cannot use the same sensor, right? Um, I come out of the imagery, let's say on the photogrammetry. If we want to, for example, extract or capture the ground under the canopy of the very, very dense forest, obviously we should use a LiDAR, right? Because
Right.
in dense forest, if it is in specifically in summer, we cannot reach the ground, right? So choosing the right sensor is very, very important, right? Different project, different objects that we would like to get, and right sensor. The other right answer, which is the no, is if you have different types of projects, right? And the definition of project is very important. For example,
Hmm.
if you are going to capture a mining area, or if you're going to capture a city area, right? You probably can do it with the same sensor, right? If you have oblique imagery in your, or oblique cameras in your system, you can capture the city area with high overlaps, right? And having a 3D mesh or 3D point cloud, dense point cloud, and defining that. And you can set up a good flight planning and mission for the open mining area with the same sensor, right? You should not change the sensor. You can just change the project settings and also the workflow.
Very good, and very good that you reply both ways. And actually, what you just said, it reminds me of a customer who indeed mentioned, you know, that sometimes they do a specific mission, and then there's a mine or a quarry like nearby, and then they just go for it as well under the same flight, do the acquisition for two different project types, right? But they can still collect data as well, valuable data that is. So that's great.
We
Thank
have,
you, Mohsen.
Michael, we have actually a data set which is in the US,
Okay.
and we captured three project
Okay.
types with the same sensor, right? So that was a forestry area, a mining area, and a city area, right?
Very nice.
And I can say it was almost in the same flight.
Very nice. That's the definition of efficiency. That's great. Very good. So let's move on to the next topic. Planning efficient missions for wide coverage. So once the sensor is chosen, like we've discussed, mission planning becomes the next critical piece. For large areas, success depends on several factors. So optimized flight lines and overlap, managing fuel constraints and flight constraints, accounting for terrain variation, and minimizing gaps while avoiding unnecessary redundancy. Sorry. So good planning isn't just about coverage; it's about maximizing efficiency while preserving quality, as we've mentioned. Mohsen, first questions for this section. What are some practical mission planning strategies you recommend when covering, you know, in the scope of this webinar, when covering hundreds, if not even perhaps thousands of square kilometers?
It is somehow related to the answers to the previous questions, but in a larger scale, you have chosen the sensor. Let's say if it is, for example, PANA as a sensor from phase one, and the object and the scene is the first thing that you have to consider. Where you can fly, where you are allowed to fly, how high you are able to fly. And these are the parameters that can define your mission, right? If you are flying over a forestry area for agriculture and forestry, the planning probably might change compared to if you're going to fly over a city area, right? A large city, national wide. And it comes back to your question on the resolution, on the GST, on the quality. It defines also the parameters of the planning. The next is how you would like to process and georeference the project, right? If you're going to just use, for example, direct georeferencing that you're flying over an area that it is not that much important to be highly accurate in georeferencing, you can reduce the number of ground control points, right? Or sometimes just remove it because it's good enough, right? If you're flying, for example, in feature or object-free areas like in the deserts, I don't know, in countries like Australia, in some areas in the US and Middle East and so on. You are not focusing on low GSD and high resolution imagery, and that's enough, right? The georeferencing is enough. But if you're going to fly over city area, dense areas, right, and you need to have a really high accuracy and reliable geometry in your block, you should think about a well-distributed ground control points, right? And this is always important to consider what is the customer's request, right? And how they will validate and qualify the accuracy and precision of the project. I think it's very important. And the other point, I would say the second point is the environmental elements.
Mm.
And it is important to be considered, in the Europe, we cannot have always a sunny air to fly, right? We
Sure,
have really some limited times to fly, and also the light and illumination is very important, and how high you can fly, right? If it is
sure,
cloudy, you can forget it. If it is not cloudy, and you can consider the clear sky, but sometimes, even if it is the sky is clear, but the sun angle is not in the right position, that you cannot avoid long
sure.
shadows, it is also another. The weather and environmental elements should always also be considered. And the last point, the third point, is the tools, the workflow, right? The equipments that you have to process it. It's also very important.
Mm. Very good, indeed. And but I mean, to some extent, you have tool phase one and solutions offers and SimActive, sorry, offers tools to counter these effects of lightning and changing environments. Is that a correct statement? You would say?
Yes, the image is one part of the data, right?
Right.
The metadata that comes with the image, right? To have it georeferenced, right? The IMU data, the GPS data, GNSS data, right? Everything is there. How to navigate it in the workflow, it is what you can do it with. It is what SimActive can handle it, reading and managing the metadata. And the challenges that you mentioned in the environmental and illumination challenges can be handled through the workflow in SimActive with radiometric adjustment, and everything would be fine at the end.
Very good. Can you know, I feel like we encounter, and I mean, I must imagine phase one does encounter as well people who tend to collect, very large projects. Can you discuss a bit about how this is tackled, on the, I mean, I guess on the acquisition side, but also on the post processing side? Is it okay to divide your project into blocks? How can the production be tackled for when we're talking, I guess an example would be tens of thousands or even 100,000 images.
In the data acquisition, I am a fan of having everything in one
Sure,
uh, flight if
sure.
it is possible. But in most cases, it is not possible, right? As I
Mm,
mentioned, we had a project that we could capture 3 areas with 3 project types, right? In maybe 1 or 2 days flight. That means we can keep the illumination and environmental phenomena in the similar and the same conditions, right?
mhm.
It will help us in the productivity, right? In the next steps, adjustment and so on. But it is not always possible if we go to a large scale, right?
Right.
Let's say it's like a statewide data capturing or national wide capturing. So the
Mm,
project will be divided, right? In the processing, if you are sure, for example, using SimActive tools in the radiometric adjustment, and you think, okay, I can handle, in the time frame of a season, having different data capturing, data acquisition, it's fine, and you can handle it through the radiometric adjustment and have the if the product is orthomosaic, you can have a unified and homogeneous orthomosaic. That's fine. But if we are talking about the processing and performance and productivity, right? Handling a project in one run, in one block, depends on what you have as equipment. Like it is the hardware, it is what you have as processing systems, processing machines. The second is how you can scale up your project. If you can distribute the processing of the project using distributed processing in multiple nodes, and this is the solution, right? You can have one block, right, but distribute the job between this different machines, right? And this is a solution um, to scale up your productivity.
Absolutely. Thank you, Mohsen. And actually, so I'll reply the same way for SimActive. If you can do the whole AT under one block, obviously it's always, the most preferred solution. And you can, in fact, like you mentioned, distribute that processing to reduce processing times. So then you can get some very interesting turnaround times. But this is actually all a good way to move to the next section and discuss managing data volume and quality at scale. So let's talk a bit about volume and quality and how you keep that essentially. So large scale aerial mapping generates, as we just mentioned, massive data sets sometimes. We mentioned tens of thousands, hundreds of thousands even sometimes we see for some customers. And obviously some key challenges appear with these data sets. Storage and transfer logistics is one of them. Maintaining consistent quality across the flights, we mentioned, that is another one. Tracking metadata and coverage, and also I think one very important one, detecting issues early on before engaging into a massive production. So at SimActive, we see teams save huge amounts of time by validating data sets as soon as it's ingested before launching full-scale production. And that's always something we've obviously recommended. So Mohsen, how do you advise teams to manage, data quality, well, data volume and data quality specifically as projects scale up? Yeah.
Perfect. I like your questions because you always put two things against each other,
Sure.
which challenge each other, right? So you're talking about data quality and then
Data volume.
data handling, right? So volume, right? Uh, if we want to have less data volume, always it is classical. You use compressions, you use, I don't know, compressions mean compressing the data format or compressing the data volume, thousands, hundred thousands of images in one compressed format, right? This is the compression. This is how in general we manage the data volume. But the quality, right? If we utilize compression format that lose the data quality, it is on our disadvantage, right? What I like at phase one images, or in what we think about the data volume and quality, is the raw format that phase one has, which is the IIQ, intelligent image quality. Uh, I think both terms, intelligent and quality, is somehow answering the question. So there is smartness of the format and that keeps the quality. So the IIQ format is a very smart and suitable format for data sharing, data handling. What I can advise is, as this format through the image SDK is integrated in SimActive, is using this format without converting that to any other data format, because in that way you will keep the quality. And if I'm talking about the quality is let's say the resolution, and specifically the dynamic range, the high dynamic range that exists in phase one imagery. High dynamic range means you have the capability to handle the radiometric challenges, right? If you have, you're flying in summer over a city area that the roofs are white, and the sun is shining, and everything would be overexposed on top of the high buildings.
Mm.
And beside that high building, you will have the shadow, and you will have the dark areas, and you will have the objects inside the shadow that cannot be recognized. I mean, we have overexposure and underexposure, or let's say top high illumination and low illuminated. You need to balance it, right? And this is the range, that high dynamic range we talk about. If you adjust it, uh, that the radiometry in image can be in a level that it looks homogeneous. Like we always capture homogeneous radiometry. It is specifically in close range photogrammetry. If, for example, the the illumination is in a cloudy way, right? There is not direct light source, right? This is what high dynamic range can adjust for you. It's like you have everything in every pixel is with the same lighting, right? And this is what we would like to keep it as a quality, and being adjusted in the workflow in SimActive, while you are keeping the data volume in the lowest as you can, right? The IIQ format is 5 to 7 times smaller than the TIFF format,
Mm.
which is a classical format in imagery, in photogrammetry, airborne photogrammetry, and is some sort of the same size and even smaller, maybe 25% smaller than the JPEG format, right? And it is obvious, if you convert it to JPEG, you will lose the data quality, and this is not what we recommend, because we are proud of quality and we would like to keep it. The next generation sensor, which is the 250, has a larger footprint. That
Mhm.
means the image size will be larger than 150. This would bring us to the consideration, okay, the data volume is getting larger. Now we are getting more challenge. But the good news is, for the 250, we have defined the IIQX, which is around 40% smaller than the IIQ, right? That means we are keeping the data volume and the image size of the raw data, while the sensor size and the footprint is getting larger. So data volume the same, but the productivity is higher.
Very good. That's something to to look forward to, the new generation of sensors. And I'll briefly mention, obviously, that in SimActive we ingest the IIQ format natively in Correlator 3D, which we've seen people uh, develop great workflows based on that very same integration. So, short question, but nonetheless very important. How early should you know QA/QC start in this process of large data sets again? And can you develop just a bit on that?
Um, it is not exaggerated if I say the QC start before planning, right? In your mind, that, okay, how can I validate my project from the beginning,
Mm-hmm.
even during the planning, and to the end, right? People always think, okay, we have now the end product, we have the orthophoto, now check it with checkpoints and see if everything is good and fine and accurate, and that's too late
Mm-hmm.
because you cannot come backwards to correct many things. The mission is done, the operation is done, and in many cases, and I can speak of, for example, some areas that they don't have always the right weather. For example, in Europe, if you miss the flight and if you miss the operation in that defined and permitted time frame, you might have missed the chance for that year, and you should have this probably next year or handle it in another way or have penalties and right. It's very important that you consider it from the beginning. During the planning, you are already planning the QC, right? You are planning the GCPs. Some of them would be as reference points, some of them will be used as checkpoints, right? You're already starting. And it's important that the accuracy of these GCPs should be also qualified, right? And always having the report of the accuracy of the GCPs. And then it goes to the planning. I would think about how much would be the quality of the GSTs and the geometry and the size, depending on the area and the scene that I'm capturing, right? If if you're planning, for example, flying over city areas with high buildings, the GST changes. Um, because it's the scale, right? It's different height and the size of the GST. Or oblique imagery. Um, the scale varies in the scene, right? In the oblique images. And then it goes to the operation. During the operation, we have tools that can validate the operation, the mission during the flight, because as long as you are in the air, you are in the mission and you can probably improve the quality of, I don't know, there was a cloud in one image and you could recognize it and you can fly it over, or I don't know, there was some turbulence in the flight and one image was not, or some images were not with the right overlap. Hey, the operator can say to the pilot, hey, we reflight this line again, right? We have tools that can recognize it and advise you to refly it again before you land. It's very important because if you land, you have to start a planning of that mission again, right? You cannot say, oh, okay, let's have today, tomorrow, or this week and check in. And no, it's in many cases not the same conditions that you have in that day, right? It's important you have the QC in the air. After that, we have tools which help you qualify your data, let's say after landing, not still the processing or workflow in the photogrammetry workflow, that give you, okay, how was the whole project, right? And has radiometric adjustment, color balancing, and so on. Then you can check, okay, the project is done well and performed well. And the next would be through the photogrammetry workflow, which you are the expert, and you can answer this question better than me. That would be the qualification of the radiometry and geometry. So
Mm-hmm.
radiometry is shadows, let's say color balancing, illumination, contrast, sharpness, etc. And the geometry would be using the metadata that we have and also the ground control points and checkpoints. And this is what comes out of the reports of SimActive and Colorator 3D.
Absolutely. Thank you, Mohsen. And yeah, I'll complete by saying that you know, the QA QC, once you switch to the photogrammetry and a software like Correlated 3D, is also, I would say, continuous. And from the beginning, you know, the first step of a photogrammetric workflow, the first module in our software is an aerial triangulation module. And I would say that's a key step, you know, really a key step in the process where QA QC should be done, or well, is done typically, and where you can really determine, I suppose, how the rest of your workflow is going to go. And then obviously QA/QC keeps going on the 3D portion, the surface models, the terrain models, and then the final product, the orthomosaic. But it's also a continuous process, I would say, at the photogrammetric level. But I like your reply. I did like your reply about the fact that you think of QA/QC before you're even up in the air. That's a good one. Let's move on to the final part, building processing workflows for massive data sets. So once the data is in hand, like we just discussed, you know, the big work begins, you know, processing data at scale. Best practices typically include, you know, we just mentioned this, but sometimes processing everything in one go, sometimes breaking projects into manageable regions when we're talking, for example, statewide or county-wide mapping projects. Parallel processing, also called distributed processing across multiple machines. Automated QC checkpoints, we just mentioned that, well, and manual ones, and standardized workflows for repeatability. So in fact, in Correlator 3D, you know, the software is designed to handle this kind of workload. It really is a production software, allowing teams to distribute jobs, automate production steps, and monitor processing steps centrally. Mohsen, from what you've seen, you know, a bit of a large question again, but what separates teams that you know struggle with scale from those that consistently deliver large projects successfully?
I think you answered this question already. I have 3 words for that.
Sure.
First is workflow. Second is workflow. And the third is workflow.
Nice.
First is learning the workflow, right? The difference is if you're looking for a workflow, that means you are thinking exactly the points that you mentioned, quality versus productivity, right? So which of them I'm looking for? Am I going to go to a high resolution, the lowest GSP? You know, in phase 1, we have data set that goes to sub-millimeter resolution and 3D mesh products and so on. Is it important? Or you are thinking about productivity. You want to be fast. You want to deliver it tomorrow. Always it is yesterday, actually. Right? Everyone is just rapid and fast, and they want to have more and more and more. And the delivery time is always yesterday, because they want, the hunger is getting more in data acquisition, right? Because the demand, the changes are getting more, and people would like to observe it. So the comparison, or let's say the consideration of quality and productivity defines which workflow you choose, right? So learn the workflow, get to know that, right? Second would be own the workflow. That means after knowing that, you said, okay, I want to have it simple, I want to have it fast, and I want to have my end products with homogeneous and high quality outputs and results, right? This is what I like really from the workflow in SimActive. It is easy to learn. It is, you know, the learning curve is so short that you can learn it and teach it, right? And that's the point where after knowing the workflow and learning the workflow, you can own the workflow, right? And the last point is scaling up. If you want to be faster, at some point you cannot, customers cannot call you, or they call always actually through the past experience that I have. Can we have it faster? How could it be? How can we run in large projects? I don't know, with hundred thousands of images in one run, and that could be done in, it is not always possible from the software providers, from the manufacturer to deliver the solution right away. But there are always um, solutions and capacities to help you to scale up that, right? If you can run one project, I don't know, with 10,000 images in that specific time, but now you have more projects with tens, thousands of projects, you cannot wait for the next release of SimActive to bring a faster solution for you. But SimActive is offering you distributed processing to have 10,000 projects and the next 10,000 is always scalable, right? And this is what I say: learn the workflow, get to know it, what it is it for me? Second, own it. That means you can teach it. It is so, you have it so good in your organization that you can teach it. And the second is scale it up.
Very good. Thank you, Mohsen, and great insights. And I think, I'll echo a bit on what you're saying, but one thing that you said, I think, is very good and very interesting. Is sometimes, we see people like, kind of wanting everything, essentially all the products, when in fact for a certain mission they would only need one type of product. So in some cases, this allows people to customize your workflow, right? And to get to results faster with the same amount of quality. For example, I would be referring to importing lidar as, a base for orthorectifying, and you could skip the whole autocorrelation portion from the photogrammetry, which would save you great amount of time. So the workflow is really customizable as well. And indeed, once you find the right success, story or success version, I mean, then it's just a matter of automating it and repeating it. And that's how we see people getting, real good success with phase one and SimActive, essentially. So very good. Thank you. I'll finish with one last question, with a bonus question, if I may say so. What and again, we're moving away from all the topics we just mentioned a bit, but it's more of a general question. What trends are you seeing in large scale aerial mapping these days, Mohsen?
I think if we observe the changes in the world,
Yes.
we can follow the trends, right? The changes in the world are in different ways, right? It is some of them are geological, some of them are geopolitical, some of them are environmental, right? Um, Change detection is something that people would like to have it more in their business, right? If we say digital twin is the foundation of the data that we have, right? We are capturing the globe in many ways, right? It comes from satellite imagery through airborne imagery and goes to drone imagery and handheld even, right? And objects in the museum. Like we are capturing the whole globe in different scales, right? So let's say at a point, I don't know when this point come, but we are very close to that. Um, we will have a digital twin of the whole world, right? And at some points, probably our smartphones, our cell phones will complete that missing pieces that are, let's say, inside, indoor, and so on. But something which makes it more important is change detection, right? We have now, once the globe, through these changes, people would like to see, okay, where is now the next change? How can I adjust my business? Where can I grow? Where is the demand? Where is the market? And this is related to your question, trend. Trend comes from the demand, right? Some people misunderstand or makes this confusion. For example, if AI is the trend, AI is the solution, right? AI will help us to answer the questions faster and more automated. You pointed on the point of in the workflow automation is very important point, because automation means improving the reliability, right? By removing the human error, right? If you do a mistake in project setup in 80, I don't know, in minus one something, the whole error triangulation will be damaged, right? The accuracy, and you should repeat it, right? This should be removed, the human error in repeated elements of the processing. The second part of the automation is simplicity. Makes your job easy, fast, right? And the last is scaling up productivity. If you have automation, you run a project, distributed processing, let's say with good machines and so on, and go to the next project and then next project. Everything goes faster, right? These are let's say the flow to that trends, and AI will help us to answer our questions faster. And if we go to the businesses that answer the change detection, right, any type of changes, people would like to have, or business and market would like to have these answers faster. And I can say the rapid processing, rapid mapping, rapid respond, rapid respond to disaster management, let's say rapid processing in mapping and change detection, and after, after earthquake, after any tornadoes. These are the demands from the market, and brings the trends and goes to cloud processing and AI. This is the direction that we are going, and in each step and phase of this direction and the path, the trends will come and go down and come and go down.
A very good, awesome reply, Mohsen. Thank you. And indeed, I like one thing that you said, that trends come from demand. Indeed, and that AI is the vehicle, I suppose, or the way to get there. Very, very good. Thank you for sharing that.
Of
Okay, so
course.
we are nearing the end of our webinar. So I'll just wrap up briefly with a few key takeaways from today. So in all this context of large area mapping, it is important to start with the right sensors, as we discussed, and acquisition settings. Plan your missions carefully to maximize coverage and efficiency. To put systems in place to manage data volume and to manage quality early, and to track it along the process. And finally, to build scalable automated processing workflows like we just discussed. So big thanks again, Mohsen, for sharing your experience and your practical strategies today. I'll finish by saying just a few points. Don't forget to subscribe to the SimActive newsletter for future webinars, for customer stories, for product updates. And I'll hand things over, sorry, to David Alamillo, our photogrammetry specialist, for a short product demo of Correlator 3D. Thanks again, everyone. Thank you, Mohsen, and we'll see you next time. Thank you.
Thank you. Sure. Thanks for having me.
Great. Thank you, Michael. We will continue with the demo portion of our webinar now. And pretty exciting news, guys. Today we're going to be processing some data from the newly released IXM FS130. This phase 1 sensor is brand new in the market, top of the line, of course, like every phase 1 product that it's releasing to the market. We're really happy to be processing this new data set and showing you guys firsthand how it's processed in Correlator and a little bit of the outputs of what you guys can expect from the sensor. So, of course, being a new sensor, we're pushing it to the limits. Today, the data that was collected was provided by our friends here at Phase 1 centimeter GSD. Can't get better than that. And the other thing is there are in IIQ format. So we'll be processing these in IIQs. So no need to go through that process of converting them in TIFFs. So let's get started, guys. First things first. Once you open up our Correlator 3D license, we're going to go to the first module on the left-hand side and see our different licenses types. Default to large format, as this is 130 megapixel sensor. Only one camera, so we'll continue with one. Continue adding our folder. And we have all our images located in this folder, and we'll select it. And of course, as you guys remember by default, I always like to remind folks, all the EXIF information from the image is displayed in this bottom box where we have our long, lat, altitude, roll, pitch, and yaw. Very common in this scenario for these type of images is sometimes you have an external file, right, an EO file, and you need to import this into Correlator. I always like to mention this for everyone watching the webinar for the first time. You can go through the three dots on the text file and browse for your EO file. So in this case, if you have a separate EO file, these were processed separately, and you have an updated EO file, you want to update those coordinates, you can do that. Select your EO file, hit open, and that will bring in that EO file. And of course, you have a couple of tools here as far as the delimiters. So if you want to separate them by space, semicolon, however you want to do it. In this case, of course, this is very common. Actually parsed by a Planix, so you get your image name, sometimes missing the extension. So this is something I also like to remind folks. You have the ability to add the extension of the image. So if they're in TIFF format, you can simply add a TIFF format and simply have the name of the image on your spreadsheet, or in this case, sometimes you have them also on a TXT file. So the next thing we want to change is, of course, these don't look like lat longs. Nah, the position system, of course, are easting northings. So you want to update your positions to easting northings, and if I remember correctly, these are times, so timestamp. So we skip one, easting, northing, elevation. For those folks who trim out the top portion of these EO files, I do a good job at guessing. However, if you can leave the first row just explaining what these are, lifesaver. You eliminate the guessing. But again, done this a couple of times, so I kind of know how they go. Of course, you have your omega, your phi, and your kappa. So again, this is the process. And what do we see here at the end? Looks like lat longs. Okay. If you have lat longs in there, prefer to use lat longs, you can always do that. So updating your position system to lat longs. Of course, that will take away your easting northings, and you can go to your latitude and longitude. So these are a couple of things you can do while importing your data. Another thing you guys can see here on this menu that sometimes folks often forget is your altitude geoid offset. If you know that your images have an offset, you can always browse for the different geoids that we have available. If you don't know how to add a geoid, and we have a great guide online, our C3D manual also covers this, so you guys can look at that. And if by any means you have any questions after reading the manual and you're like, I still don't get it, how do you add a geoid? Please feel free to create us a support ticket, and we will be more than happy to help you guys go step by step to add the geoid you guys need. However, no Joe needed on this one. And again, we can cancel out of it because we're not going to use an EO file. So we're simply going to select and oof, I need to add my images where are on this folder. Select. There we go. So now that we have our images in place, we're going to continue with the EXIF, just with the geotags. Hit add. We're going to go and come into our projection. Very simple. Again, we don't have any GCPs for this particular project, so we're going to continue UTM. Again, if you have GCPs, you want to match that GCP projection. And if you have any other external files like LiDAR coming in, remember guys, you want to match that projection from the LiDAR. No issue here. UTM is fine. Hit OK. We will continue through the process of importing 33 images. Hit next. And we come into the camera parameters. So as you guys can see at the top, we have the IXM FS130 from phase 1. I'm not going to go into details of the camera parameters, of course, because we're just going to go with the defaults right now. Once you guys purchase your own camera, of course, you might have a calibration certificate file. Well, you can copy paste all the elements you need from that particular certificate. In this case, we only have focal length, pixel size, and we'll get great results just with that. So let's hit next. Finally, where are we going to save the project? So as you guys know, I always like to remember, folks, let's save it to our C drive, and that will give us the fastest reading and writing speeds. I'll never work from an external drive. I've made that mistake in the past, and the project was supposed to take, I don't know, on top, it was a large project, maybe 2 or 3 hours, ended up taking 4 or 5. So I learned my lesson really quick. Working from an SSD drive NVMe. That was one of the main updates I did to my processing PC, and it made all the difference. So again, prompt you guys. GPU as is important as the storage, I would say. Select the project where you're going to save all your files. And I'll take this opportunity because I get this question a lot is I want to bring in a DEM file. Can I bring a GCP file, reference ortho? Well, you can, because obviously the project parameters allows you to do so. I like to remind folks, I like to see where the images are placed on geographically on the background. Sometimes the DM I'm bringing in is not in the same coordinate system. And I assume it is just because I downloaded it from a website and I was like, yeah, this seems like it's in the same coordinate system. And I open it up and it's nowhere to be found. The GCP file, same thing happens to it. So the GCP file won't display the GCPs, and then we'll realize, oops, it's in a different projection. So to don't have to go through this process twice, I like to just import my images as a first step and hit finish. And this will obviously allow me to see, first of all, the background imagery of where these images are located. And if this is done correctly, then I can import my DSM, my reference ortho, my GCPs as a secondary step. So the first thing I'll do if I need to import a DM would be go to the DM portion of the project tree and browse for the DM I want to import. Again, the supported files are, of course, our native file SMF2, SMF, or TIFF file, or ASCII grid. So these are the formats you guys can import that. Same goes with the reference ortho. You guys can select the folder where that reference ortho is all located, and the software will import them. And finally, the GCPs need to be done through the AT. So yeah, that's the only difference here. They're not imported through the project tree because the GCP file that the software requires is a .gcp file. So you guys will see here in the project tree is .gcp, which is created as soon as you guys import your GCPs into Correlator through the AT. If you go to the AT section where the software is right now, you guys will see a .gcp file, which is again something you guys can import through the project tree, but it needs to be created first. So now that we have our images imported, we said we imported 33 images, right? Camera count 1, group count. We can always look at our individual images in the flight in the project tree and remove any flight lines that we need to remove. Very important. How do you clean up your images? It's through the AT module. So let's go through the process right now. We have some time here. Go to the AT, and we're not going to do a type point extraction just yet, so we're going to say no. Go to the plane with a pencil, and let's go ahead and remove flight line 1. We don't need you. And we're going to click our flight line editing tool and remove it. And voila, we only are left with We removed 11 images, 22 images. We made a mistake. David, bring those images back, back to the future, back to the past. Remove our images, and there we go. 33 are back. As simple as that. I always like to cover this in most of the demos I do because it's one of the first things I do when I receive a data set. Now, again, this data set is great. As we mentioned before, it's from a brand new sensor, FS130. Um, and again, 1 centimeter GSD. By golly, I remember when I used to fly these and there used to be not even close to this resolution. So again, good job to those manufacturers out there who are pushing the limits of those sensors. Again, nadir mapping benefits so much from nadir. I get this question asked a lot too: is how much benefits do I get from oblique imagery for mapping? And the answer is not much. Again, depending on the analysis you guys are doing, and depending on, of course, the work you're doing post as 3D models, point clouds, yes, they might benefit. But when it comes necessarily to mapping purposes, I would say no. Stick with your nadir images. You process great and fast. So as this is a great data set, I would actually, and no GCPs, of course, I would actually process it through automated workflow. Super simple. Go to the automated workflow module. Again, update your settings as you guys need to update your settings. Of course, the resolution of the DSM is one thing I always update. Optimal, remember, it's 5 times your max GSD. If you need to update this, of course, you can set it to not maximal, but say twice. 2 times your GSD, 3 times your GSD is perfectly fine. The next thing I always adjust is if I need a true ortho or not. Kind of given if I need a true ortho, then of course we need the DSM. We might not need the DTM in this case, but you have a couple of options to update here your profiles. And once you're ready, hit process. Now, if we were to process this data, how long would it take? Well, I have some timings for you guys based on the sensor. And of course, here I'm pushing a little bit the boundaries of my GPU. No, not even. It's the RTX 2060. When I say I'm pushing the boundaries, because most of you guys will laugh at my GPU and be like, "Oh, he's not even running a top of the line GPU." That's right. And actually, we do this on purpose. We want to show you guys that with a standard GPU, something that's not top of the line, millions of dollars, you can get great times. And this is just to prove how well and optimizes Correlator 3D compared to other solutions. So again, NVIDIA GeForce RTX 2060 running 4 gigs of RAM runs perfectly fine. I process here the type point extractions in 4 minutes, bundle adjustment 17 seconds, 5 minutes for my DSM, DTM, about 1 minute, orth rectification for mosaic creation 11, so a total 26-minute for those 33 images. Again, great timings and barely pushing the boundaries here of my GPU in this case, because of course Correlator optimizes all those resources. One thing I'll note in this video is a lot of folks try to see the work that the GPU is doing in the background, by monitoring the GPU usage, and you're like, well, it's not even using the full power. It's because we're really optimizing several parts of your hardware to do the processing. So we don't want this to be a bottleneck or really push the GPU to the limit where your computer starts smoking and dying. So that is, in some senses, and I've told you guys just a couple of emails that I've sent out, is a true proof of what an optimized software can do, and use your resources as smart as it can. So again, wanted to show you this, but let's take a look at the full project now. Let's open up our full project here to see some of the deliverables that we might have. So bear with me here. We'll open up our project. And once our project is loaded, we're going to start off by our DSM. And as you guys can see, we have some great options here. We can actually run some volume calculations using the software. Again, for any of you guys who missed, I think it was 2 webinars back in, and we actually talked about the different tools to create your volumes and your reports. So you can simply use the volume selection tool and generate shape files around those stock piles, and you can output a very nice PDF report. Same goes with elevation profiles. But just to give you a little bit of the details of how the DSM looks, it looks amazing. Again, amazing sensor. So these are some of the things that I like to highlight when you're doing your QA/QC. Again, you can crop your DSM using the tools found in your DM editing tool. So I like to crop my DSM prior to generating my DTM. And once my DSM is cropped, then I go into the DTM module and generate my DTM, which of course it's automatically cropped, because if you guys remember, once you crop the first DSM, all the output and products generated from that DSM are automatically going to be cropped. So my DTM is going to be cropped to that extent. Therefore, if I use any of these two layers to ortho rectify, guess what? It's going to be automatically cropped. So that is a great advantage. One thing I'll note, when we go into the ortho rectification module, you have two options. The first option here is to ortho rectify in 16 bits or 8 bits. And so those are basically the two options we have. Now, the next thing I'll point out is, of course, if we go through the ortho rectification stage, can you have more than one ortho rectification folder? Absolutely. Can you have 16-bit and 16-bit and 8-bit? Of course. The only thing you need to do is, after you finish ortho rectifying, let's say you did 16-bit, you're going to go into the plus folder and going to create one that says the plus button and create another folder for your 16-bit. So that's super simple. Simply go to the motion and create a new ortho folder, and it won't overwrite your run. Now, in this case, we also did our mosaic. And so we're going to go to our mosaic here, reference ortho. And as you guys can see, it's a 16-bit mosaic. Looks great. And one of the things that I also wanted to show is a 3D model we did, which of course looks pretty amazing. And the next thing we'll turn on is, of course, our 3D model. And to view our 3D model, let's go to View, 3D View, and let's go full screen. So we can zoom out a little bit to see, again, that area where we were. We can always switch between 2D or 3D. That's something you guys can do with this button, swap between 2D, 3D. If you want to get a more overall view of that, you can simply zoom out, go to a 3D view, and that will give you a bit of a reference. Again, really good looking 3D model. Pretty amazing. That's when you package a great sensor with a great software. And finally, just to give you a little bit more details, let's load up that point cloud, which usually takes a little long, but we'll save some time here pausing it. And once we load our point cloud, we're going to remove our 3D model. Let's take away some stuff here and look at our point cloud really quick. Great looking point cloud. And of course, you can export all of these outputs that I've been showing you today. But yeah, this is a great overview of the Phase 1 FS130 IXM FS130 1cm GSD. Man, they're pushing it. And of course, process it with Correlator 3D. If you guys have any questions, always feel free to reach out through our support portal. We're more than happy to give you guys the latest and greatest when it comes to support. But also, feel free to stay tuned for the next webinar. So thank you very much for your time, guys.